All right, started.
Okay. Hey everyone. So this time I'll be asking Sean a uh algorithm question as well. So Sean, um, this time uh I'm gonna give you an array of integers, and I want you to determine whether or not uh oh sorry, let me start the time. So like I want you to determine whether or not uh there's a sorry. So you have an array of integers,
Mm-hmm.
and I have a specific target. I want you to determine whether or not there is a contiguous sequence that adds up to it. Can you share your screen with me?
Oh, whoops, sorry.
And then, so what that means is, yeah, if there's a,
Okay,
Mhm.
so can we assume they're all positive, or they're negatives too? Not
um,
that it matters really, right?
we can assume that they're all positive.
Okay. And you want a function that returns true or false
Yep.
based on if it can find one. Okay. Determine sequence that adds up to it. And your input would be an array of int and then like a target.
Mm-hmm.
Okay. And are we assuming that array always has members in it or no?
Yeah. So it's
Okay.
always, it has at least one element.
Okay. Okay, so example would be 2, 4, 3, 7, 5. And the sequence we want to look for is like 10.
So let's use that, and let's try to find something that exists and something that doesn't.
Okay,
So yeah, 10 would be a valid contiguous sequence, contiguous sum.
yeah. Um, let's do like 16. 60 is bad. I think for 6, 9. No, this is no, 16 is actually good.
So let's say 99.
Alright. Alright.
Or one wouldn't work.
Okay. Um, so we know we have to visit every member at least once
Hmm.
to find this sequence. I have a feeling we can do it just like through in one pass.
Hmm.
Um, so I guess I can, let me just walk through it. So I have
Okay.
2. If my target's 10, I have 2. I would say, is this greater than 10, equal to or greater than 10. And now it's less than, you keep adding.
Uh-huh.
So when you add 4, you get like 6.
Yeah.
Is it 10 yet? No. So you keep adding. Here we have 3. Oh, so oops, sorry, 9. And smaller still, so you keep going. Now you have 7, and all of a sudden you have 16.
Yeah.
It's bigger, so what you can do here is you can drop your 2 before moving on and see if that is good. So I guess when you drop the 2, keeping a pointer here, you actually know what it is. You can minus 2 to this. This will be 14, so like this is like out. And your pointer is here. It's still bigger than 10. So I guess we can keep subtracting it. This will be 8. Now 8 is smaller than 10.
You sure you have that right?
Oh god, I don't. Oh, sorry, this is 10. Alright, so it's 10, so that's good. Okay, now is there ever a case where if this was 5, actually that will be 10 if it's 5. Maybe if this was 6, just to explore. This would be 8, 11. Okay, let me just do a quick other case as well.
Yeah.
So instead of 4, this is 6 now. Use a different color. Also, rest in peace, paint. So you have 2 plus 6 is 8. Plus 3. So in here you don't have a sequence. So this will be bad.
Are you looking for... Okay, yeah.
Yeah, I'm just looking for 10. I'm trying to find an edge case where like this doesn't work out, but I might be wrong in thinking that it probably would all the time.
So let's see what you have.
Yeah, this is 8. This is 11. It's big, so you cross this out. This would be 9. It's smaller, so that's 16. That's too big, so you cross out 8, and this will be 8. And 5 is 13. And that's too big, so you cross this out, and that's 4. And you reach the end, so there's nothing. Okay. Well, you're at 4, but you've reached the end of your list. And it's smaller, so
I'm not sure if that's right. How did you get 4? Are you sure?
Oh crap, I'm keep subtracting the wrong number. Sorry. So it's 13 before. Minus 3. Wait, okay. Alright, let me do this over. 2, 8 here. 8 plus 3 is 11. Now you take out 2. This turns into 9. 9's smaller, so you keep adding. 7, that's 16.
Yeah.
16 is bigger, so you cross out 6, and that's 10. And that's good. Okay, and then you've gotten 10. We don't care if it's like the longest sequence or the shortest sequence, right? Just a
No.
sequence.
Yeah.
Okay. Alright, so I guess these work. I'm
Mhm.
gonna find. So let's do like 99.
Mhm.
I'll make a new color. Wonder if I could erase bigly size. Wow, I guess it's better than nothing. Alright, so in the case where it's 99, this will be 2 smaller, 8 smaller, 11 smaller, 18 smaller, 13, or 23. And you're in the end, so it's nothing. If it's 1, do 2, it's too big. So you move up, it's 8, and that's too big. So you keep pushing your, like, head track, like your your start tracker forward in this sense. Until you get something smaller than 1. So each time you move your head tracker, you need to check if your tail is also behind it. If it is, move the tail as well. So that's like something we need to watch out for. Move tail if behind head. Okay.
I think we're ready to start coding.
Alright. So okay, let's jump into coding.
If you feel like you want to work it out a bit more, that's fine. But
I think I'm fairly comfortable with this. Okay. Alright, so to go public boolean has sequence sum, and then I'm giving an array input, and then int target. Okay. First thing I want to do is it guarantees 1 element, so we can initialize our indices. So int. So let's say we have a start and an end. Start index equals 0, and then end index equals 0. Now during my loop, oh wait, we also want to keep track of current sum. I guess that can be 0 for now. So I want to loop through I'm trying to figure out what type of loop I want it to be doing. Maybe a while loop? Because maximum, yeah, it's not always guaranteed. We know how many ticks it would be, but maximum it would be 2 times the amount of the array in terms of traversal. So let's do a while loop. I guess while the head or the index is not at the end. Oops. Start index not like less than input dot length, or no, let's do an and do we need an and? I think we can just keep track of the end index because we increment that anyways. Okay. Now there's several cases. So case 1, current sum is less than target. Case 2 is current sum is greater than target. And I guess current sum is target. Is target. And if we ever make it out of the while loop, that means we didn't find our answer. And then we just return false here. But if the current case is target, return true here. Okay. If let's do current sum plus equals plus equals target, no, input and index. And if current sum, so here we can do the check. Target, do something else if else current sum is target, return true. If it's less than the target, we keep going, so we increment end index, and that's it. If it's not, though, then we need to subtract the end index or the start index because it's too big already, and then increment it. Current sum minus equals input start index, and then start index plus and that end index plus. Okay, so I think that does the job, so I'm gonna walk through an example. So my input is this, so input 26375, looking for 10. My target is 10. Let's try another target that's valid here.
What a 3-digit one. No.
A 3-digit target?
Or
I want to try one that passes first before I try one that fails. So.
Oh, I meant like using 3 of the numbers.
Right. Okay. 16. Did I do that already? Let me add more digits to this. Might be a bit better. Okay, so I guess for my example, maybe I'll do 751, which is 13. Okay. So here I'll keep track of current sum. Start index. Okay, so everything's at 0.
I think you should try looking for 10 still.
Okay, sure.
Yeah. And if that works, you can try other things.
Okay. Start index is at 0. End index at 0. Current sum 0. So end index less than, so input length is 1, 2, 3, 4, 5, 6, 7.
Let's write that down as well, because that doesn't change.
So it's less, yes, it's less. Current sum input at index. Input at index 0 is 2, so current sum is 2. Sum is less than target. Target is 10, so it's yes. End index increment, so this becomes 1. And that's it. So the second loop, end index is still less than 7. So, well, yeah, so current sum plus input length, so it's 6. This will be 8. And then you increment the end indexes again. So it's the third loop is still less than length. Add 3 to this, so this is 11. All of a sudden, you get here, because it's greater.
That's isn't it? But then you don't. So you
add
that,
the 3.
Yeah, so after adding 3, it's 11, right?
Right.
And then
it's now current sum is greater than target, which is 10. So current sum minus input at start index. Start index is 0. So you minus 2, that's a 9. You increment start index 1, but you don't increment the end index unless it is the same. Yeah, okay, so here I'm missing something. If start index is greater than end index, start or end index equals start index.
Okay.
But so you don't increment it. So you do a check there. Okay, now keep going. Let's see. So current sum's 9 now. My next loop, end index, is still 2.
Okay.
So I do need to increment end index, because I'm adding it again here. Else. Does that make sense? Okay, I think I'm getting I'm like off by 1 loop here. If I,
Do you always have to add something, or do you only add under certain conditions? I'm saying, do you add an index?
yeah, so there can be cases where you minus the current sum and your answer is right there. So
I don't think this part looks okay.
okay, so I think what I'm missing is a check here. There'll be cases where you subtract the last one and you just have the answer already. But if you don't have the answer, you take this out. This needs to be here, but end index also increments. So I think this works. So let me just keep going with this example. I've taken out the 2. Okay, which is 9 now. It's not target. I increment start index. Did I increment this already? Yes, right? And I increment end index, which is 3. So now when I add this again, this is current sum input 16, because it's added to 7. It's too big, so I take out 6 at index 1, so this is 10, and during my check this will be true, so I just return true immediately. So that's good. I know it's not the most elegant. I do think this will work for most cases, for all cases.
Okay, so let's look at the previous case. What if I said what if I gave you a target of 0? What do you think would happen?
That would be true. If you give me a target of 0, I can argue that the sequence of an empty subset gives you a sum of 0. Is that correct?
Let's say that you can't. Okay. So
Damn, okay.
let's say, yeah.
Okay. If my target was 0, I should just return false immediately? Well, guarantee that everything is positive in my example. We already know, but if there's a 0, I guess, does 0 count as a positive number in your...
Let's say non-negative instead of all positive.
Okay. So my things can have 0 in it.
Yeah.
I think the lazy way is just to do a lazy check to find if there's a 0 inside your input. If target's equal to, so this is like a special case. I don't know, like, let me try to figure out there's other ways to tackle that.
Well, let's leave this aside for now.
Alright.
Because I also wanted to address some other things.
Sure.
So, in your while loop, the condition is if end index is less than input length, right?
Right.
So, let's say if end index could run. So, if we look at your example down here, input 2, 6, 3, 7, blah blah blah.
Mm-hmm.
If end index was at 4, so let's say your target is the sum of, well, maybe it's just like, it's less than everything minus 4.
Mm-hmm. Mm-hmm.
But what I'm saying is, if you, what happens if you add 4 and it's greater than the target?
If I add 4 and it's greater than the target,
Yeah.
so that's this statement here, I will decrement it with like 2 and check if it's the target, check if it hits the target, and increase the 2 indices here. So granted that, so when my end index is at 4, this member here, it's the end index is 6, and then I increment it. Oh, so you're saying if there's a case, so I need to like do a while here instead of a
I don't
one.
think you need to do a while there, but I'm saying, like, what if after you add 4, it's greater than the target?
Yeah, I know what you're talking about.
But by that time, end index will be the same as input length, and you won't run the while loop, won't run anymore. So
yeah. So I need another loop in here to loop until it is smaller.
So I'm not really following that. But
right? So let's say my last member was like 99. and my target was, I don't know, 100. I want these two, but these aren't going to add up to 100 until you hit 99 and it gets over by too much. Now what you want to do is start decrementing.
Yep.
So yeah, I mean, either we can do a loop here or we change this condition that end index of end index. So maybe we want to say end index and start index. Oops, sorry.
It's fine. I think whatever works for you at this point.
Yeah. Yep. Okay. Yeah, but you're right. So here maybe say if end index I mean, I see what you're saying. I'm doing this add here, so I kind of screwed myself over. But instead, we should add first. I guess, should we add? We should add inside this. Okay, if current list on assistant target add it. If it's greater than then you subtract it. Let me turn the AC, it's really hot. So add it and then increase the end index. Okay. Here you subtract give me a moment to parse this out. I guess I would move this to the top. This is true. If it's too big. Ooh, if it's too big and I'm at the end, I don't want to increment. Don't want. So let me see if this works. We have two current sum is 0. Okay. Sorry, there's like a fly in my room. It's really annoying. Alright, let me check it with this 99 case. So you add 2, 6, 3, 7. Next current sum. I guess at the last iteration, right, your end index would be at 6. Your start index would be at 0. And it's going to be less than, so you keep adding an index to it. So now you want to hit this. Current sum would be 2, 8, 11, 18, 18, 23, 24, 100, 30, 3, 100, 23, right?
Yep.
Okay. Okay. So now when you keep doing this, so start index at 0, end index at 6. It's gonna keep hitting the else.
Yeah.
I guess this is else. This. Whoa. Yeah, I guess, I mean, there's no need for this because this is guaranteed.
Okay.
So minus current sum at start index. So 121. It's not it. Start index increment. It's gonna go back. Increment start index be 1. Go back 6. So okay, so it's gonna start minusing. And that's like 15. It's not it. Keep incrementing. No, 3, 2. This is 3 now. So minus this is 5. 150. Oh shit. 105. Start index increment 4. Now we're at 5. Now we're at 100. And this is true because it's at 100. So it returns true. Okay, so I think that's a better solution, or more accurate. Alright.
Yeah.
The runtime would be linear with no memory, or constant memory.
Okay. Okay, I'm gonna stop the timer here.
Okay.
That was 43 minutes. So let's see. Okay. Yeah, I don't know if the part you highlighted. I don't know if that can be. I don't know if you can remove it or not because you're doing the check anyway. But
right.
I don't know. Yeah.
No, I think so. I think I'll just have to do equal. Well, that'll break it, I think. Alright, I'm just gonna keep it here.
Yeah. Well, it's slightly different from my solution, so I don't know if it'll work for all cases, but I think it looks okay to me, at least. Yeah. So, time-wise, you came up with the solution pretty quickly, but I felt like in terms of coding, you had a bit of trouble with like the special cases. I don't know what you can do about that though. Um,
What'd you do for
why
the zero case?
actually? Why don't I share my solution
Sure.
here? I can share my screen as well. Uh, See it?
Yep.
Okay. So actually, I made it so that it would run the the check as well.
Mm-hmm.
So what I did was, so I actually started with
So
the
you
first
summed
would be
it already.
yeah. So
Okay.
actually, I I started with the first element.
Mm-hmm.
That way, I didn't have to deal with special values like 0. So with that first element, basically, I already have something in the sum, and I go through the array. So if the sum is smaller than the target, then what I do is I I add the next number, and here I set last to 1 instead of 0. So actually, I just add the next number and then increment
Mm-hmm.
last.
Mm-hmm.
On the other hand, if the sum is already greater, then what I do is I remove the last number that the you know what I mean what I mean, right? The number at the top of at the beginning of the sequence,
Mm-hmm.
the contiguous sequence, and I increment first. And here I also do a check. So oh, I don't know if you're missing that, but this you talked about this, but I'm
Oh.
not sure if you forgot this in your code. But so I want to make sure that the I'm not adding stuff that I removed already. So
Right.
last should always be uh, the
I did
same
remove it.
or greater than first. Yeah. So
Yeah.
if it's not, then I just set it to that to the same thing, and I actually don't add anything. I just set it there. I set it to the same index, and at the end I do a check. So this happens after I add or after I subtract.
Mm-hmm.
And let's see. So yeah, that's pretty much it.
Okay, so if I remove this out, so I shouldn't have moved this check to the front. I should
Well,
have
I
just
don't
left it
know
in the
if
end here.
I think it might have still worked if the
Yeah,
check was
it's
in the
not as like
because
nice though, right? Like that. So if that was the case, I don't need this for sure.
I mean I don't know if like you did it slightly differently. I'm not like I don't know if but I don't know if you need to change it. You know what I mean?
Yeah, no, I think this is better, prettier.
If you change so even if you checked for equality in the beginning, I think it would have I would have
Mm-hmm.
worked.
Um,
Well, unless
unless the start index increments off. But this requires both of them to be
I think
off.
it might not work for some extreme edge cases, but
Mm-hmm.
actually I don't know.
Well, yeah, I guess if the end index is equal to the start index,
Oh,
you
I
increment it
guess if I guess it wouldn't if you had the equality check in the beginning. It wouldn't work if your target was the very last element
Mm-hmm.
because it, yeah,
Mm-hmm.
this should be okay. Wait, let me compare it with mine. Yeah. Oh, but I guess here on line 22.
Oh, yeah, you're right. Nah, this needs to go first. Start index needs to
Yeah.
increment first before you do the check.
Yeah.
Yep. Alright, now ours is exactly the same.
It is.
Almost.
Yeah. So I don't. Um.
Yeah, so.
Yeah.
Yeah, I think it was much easier if I just started with the first element instead of. So there's no need for this 0 check here. Okay, yeah. So this is my feedback.
Aside from that, I don't. I mean, I don't really have any helpful feedback.
No, this is helpful, I think. I think with every time I do while loops,
Mm-hmm.
I get the thing that like confuses me the most is like when should I increment?
Mm-hmm.
Should I do it in the beginning or should I do it at the end?
Mm.
And that's like that always throws me off a little bit.
Yeah, it's the edge cases, right? It's like the beginning and the end.
Yeah. While loop. Increment in beginning or end. Yeah. So I think starting with the first element would be really helpful here. All right, thanks, Greg.
You're very welcome.
All right, so I'm gonna stop the stream. See you guys later.